Okay, hi everyone. My name is Asriel, and I'm going to present to you this thing called .ix, short for dot interactive, and it's a diagram generator. And it's all about creating diagrams quickly. If you need to have the link, I can share the link around later. So once it loads, now every day when we work in software, when we write documentation, we tend to create two kinds of diagrams. One's a process diagram where we have step 1, step 2, step 3, find a bug, fix a bug, ship a bug. You might have process diagrams which fan out and like diverge and converge, but essentially they are just showing you sequences of some process. And another kind of diagram we work with is deployment diagrams. So if you are working with any cloud-based infrastructure or even on-premise infrastructure, you tend to draw something like this where you've got rectangles, boxes, what's a server, what applications are in that server, what's a network, what's the sizes of that network. So we tend to make many kinds of, well, many variations of these diagrams in our documentation. But I tended to find if you work with diagrams, you always encounter problems. So first kind of problem you encounter is the appearance of a diagram. It's very annoying to change many objects. So when you have, say, 10 objects and you want to change the style of those 10, if you're using a visual tool, like the poor kind is you have to click on each object, change the style, paste, change the next object, and so on. If you're having a tool which has a bit better support, you might be able to change one object, change the style, copy that style, and paste it across to the other 10. But what I really wanted is change the style once, everything changes, right? Because the speed of thought should be the speed of your software. So another problem with appearance is you add some text to a node, and now it's gotten a bit bigger. You need to position everything else a bit further away. And who knows, if you copy that diagram, let's say 3 times, now you need to update 3 diagrams. And it's like, it's work, which is, it's very easy, it's very tedious. So I didn't like that. And second problem is accuracy. So normally when we create diagrams, we probably create them with accurate information. So if you have infrastructure, you've got some networks, you've got some servers inside those networks, subnets. And let's say you change your infrastructure to have, instead of using beanstalk servers, you use lambdas instead. Now, normally people make code changes much quicker than they make documentation changes. And who knows, if you add infrastructure to your infrastructure by hand manually, then usually that doesn't get reflected in the diagram. So you get the problem of drift. So someone looking at the documentation will not actually have an accurate mental model of what is. So what I wanted to solve is, I don't want that drift. Third problem I was considering is portability. So when you create a diagram, there's kind of 2 parts. One is the input. How do you get information into the diagram? And one is the output, which is usually pixels or some scalable vector graphics. So some renderable information. Now, these 2 bits have their own issues with portability. If you store the input to a diagram, you need a tool to transform that input into the diagram itself. Because the input to a diagram is not the diagram. You might have some third-party tool like Glyphy or Lucid Diagrams, Mermaid.js, Dots. All of these have their own syntaxes for input to their tool. Then when you switch over to rendering the diagram, you can take a screenshot and that's the output. Now, if you store the output, it's very easy for anyone to see it. So say you copy those pixels, paste it into internal documentation sites, into a chat, into anywhere, you can see the diagram, but you cannot update it, because to update the diagram, you need to change the input and have the tool. So what I wanted is, well, I need to store both, kind of. And if I store the input, then I still need to make the tool freely available. And finally, information dynamics. So diagrams normally have one level of information, and they are quite static. So I'll show you an example. So over here, we've got a very simple diagram showing us a request going from our computer to GitHub. I want a file called app.zip, and it might respond with, to me with that file, and that's like quite easy to understand. Now, as we increase the amount of information in the diagram, let's say we've got similar thing and a few more lines. Over here, you may need someone to narrate what happens first to know what happens first. You can't just look at it and grasp it immediately. You might be able to work it out, but it's a bit harder. And just to prove the point, you can also have a very big diagram where it's quite hard to see where the lines go, right? So this is just a real dependency graph, and it's actually quite a small app.
What's the language?
This is .ix itself, the playground, right? So I do have the .ix playground and all of its dependencies here, and we will see the actual thing in as a demo shortly. So static diagrams, very good for small bits of information, good for printing, because you see it on screen, let's print it out. But not very good when there's a lot of information, there's information overload. Now, we can try to make the information a bit more dynamic. So this is kind of like the first example, but we animate the request. The line which goes up there, it comes back down a bit bigger. And so we can show the sequence of information flow using animation. But if you just have a static animation, then you're kind of bound by when the animation is moving. You can't really explain it well. So I really wanted to have something more interactive where I could control the flow of what's shown on the diagram. So if you have an interactive diagram, then let's say I want to explain what a request is. A request from your computer to GitHub might involve, say, DNS lookups. You connect to the IP, you might have some SSL handshake, and then you start talking, right? Then once I've fully explained a concept, then I can talk about the response. What happens from GitHub servers to our computer? They might fetch the file, they might stream it, they might be reading the information on disk and stream the bytes to us while reading, because maybe if you read all of the file into memory and then stream, that's less efficient. And if it's a huge file, you're just going to exhaust a lot of memory, which you don't need to exhaust. And when I'm done explaining that, then I can say, hey, and that's how we get our file download, right? So this is where I can control what information I show on the diagram. And that way, if someone says, oh, I didn't understand the first part, you can go back and explain the first part. And I think most of you would have experienced this kind of level of interactivity, but on a whiteboard. And you know, on the whiteboard, when someone says go back, you have bazillion arrows already, and you're like, oh, let's erase some arrows, and you redraw a few of those. It kind of works, but it's only there as long as the whiteboard's there. And you can't go back to it like the next day and hope that the whiteboard's not used, right? So I wanted something persistent. So those are all the problems. Now I needed to find a useful solution. So I came up with, well, for the output format, if you think about portability, PNGs, portable network graphics, it's got portable in its name. It's probably portable. It's pixels, and you can upload pixels anywhere. It's safe. And can you add styles to nodes in a pixel diagram? Yes, you can. You can render the styles, put it in pixels, and then just render the image. Is there lossless resolution? Can you zoom in forever into a pixel diagram and have it be rendered sharp? You can't, because you get pixelation. And is it interactive? Click on the pixel diagram, nothing happens, right? Is there dynamic level of detail? If you click on it, do you see more information? No, right? So you get no marks for that. Now, second format I looked at was HTML, HTML elements. So can you upload HTML to any external service? No. Well, I mean, if you can, you probably should question that external service. But let's not disregard HTML first or yet, because in terms of styling, you can style HTML elements really well with CSS. You can change the sizes. You can have dynamic layouts. Can you have lossless resolution? Well, if I zoom into this page, you can see that the text is very crisp. There's no pixelation. So any element rendered using HTML will have lossless resolution. You can zoom in forever. If you need to make a really huge physical poster and they say we want a big image, if you had something made using HTML elements, it will print nicely. Is there interactivity? Yes, you can script stuff. And is there dynamic level of detail? You can have details panels, or you can click on an element and make more information show up somewhere else. So there is dynamic level of detail. Though at that point, you may question, is this a diagram anymore? Maybe not, right? So the reason why we don't disregard HTML is because if we are in control of the web page, it's a viable solution. And finally, we'll look at the middle option, SVG. Can you upload SVGs externally? Some places. GitHub takes them. So that's why it's like, oh, you can upload SVGs. I'm already happy with GitHub just taking it because that shows I can do stuff. Can you style SVG elements? You can. It's kind of like HTML, as in you have CSS styling. You have inline styles you can embed into the SVG. But the elements are a bit weird. They're statically sized, so you can't have the dynamic sizing or margin like HTML can calculate for you. And is there lossless resolution? It's scalable vector graphics. It is scalable, so there's lossless resolution. And is there interactivity? You kind of saw it earlier. There is some, and the challenge is getting that interactivity without using scripts, because you can use scripts in SVGs, but then most places will block those. Finally, dynamic level of detail. Can you click on something in an SVG and make something else appear? I don't think you can, but I haven't researched this thoroughly. So if you can turn that red into a yellow or green, I'll be very happy. Cool. So that's only the output format, which I considered, right? Now, input formats, we want to solve things with, we want to solve easy multi-object edits. So if I change the style for one thing, I want everything to change, which is the same type of thing. So if we use a text format and use find and replace, that will be our easy multi-object edits already. If you have a good text editor, you can do this quite easily. I wanted the input to be compact. So if I specify the styles for, say, a subnet to be blue, and I wanted multiple things to be subnets, then I should be able to say, hey, use the styles for that one thing. And so instead of defining blue for every single subnet node, I should define it once and reference that same definition. So if we use YAML, we can have referenceable values. So that's why I chose YAML. Can we have out-of-the-box styling? Because we know some formats like dot, it's got a text format, and you can input the information, but the styling is quite manual. There's like HTML-like labels, but then it's still quite verbose to write those by hand. So I think Mermaid.js, which has GitHub support to render in comments, they won because they got good default styling. So I wanted out-of-the-box styling for my solution as well. So if you input your information for your diagram, it renders kind of okay nicely. We can change the default theme as well. So we can improve on that without you having to update your diagram input. And finally, if I do want to customize this styling, then let me. Cool. So that's input. Now, the final thing I had to consider for this .ix solution is I didn't want to pay money to host the service. So the first two problems with logistics is, can I have free hosting? You can generally get free hosting from GitHub Pages and some other places, but GitHub Pages was good enough. And I wanted no web server, because if I have a web server to render a diagram, there's problems with receiving IP. But to me, the problem was really if someone tried to attack me, then my line of defense is my credit card, right? And my credit card ain't that big. So I was like, I'll make it client-side logic. And if you have static web page with client-side logic and you render the diagram on the client side, you have no load issues, you have no security issues that you have to worry about. And as long as you maintain that rendering client side, there's also no IP being sent across the line. So people who are concerned with that, they don't have to be worried that someone's going to steal their ideas. So in that line, the third logistical problem was, can I share the diagram easily within people with my organization? Remember, there's the inputs and the outputs. So if we store the diagram in the URL, and you copy that URL to your colleague, then we've passed them the input, and they open it, it renders the diagram, you've shared the diagram. If you copy the SVG that's rendered, that's also copying the diagram, but you're copying the output. So that's a different way of sharing. So that's what number 3 was. And for the no IP transmission, I store the diagram in the URL fragment. So that's the hash and then the bookmark. You can make your client-side logic read the bookmark. And that's where I get to have really big diagrams. The browser doesn't send that part of the URL to the server. You don't hit GitHub's request size limit, which is 8 KB. And because everything is read offline, you're not sharing the IP. So all of those concerns were alleviated. Cool. And at this point, let's look at it, right? Too much information, let's just look at it. So we'll start simple. Cool. So on the left, you will see a text box, or it's actually VS Code in the browser. So it's Monaco. So you are able to select some text and multi-cursive select that if you need. So you can see I've got I can edit multiple nodes at the same time. So the text is your input to the diagram generator, and the diagram is rendered on the right. Over here we've got a simple diagram hierarchy, and then the hierarchy shows you which nodes are in the diagram. The edges link nodes to each other. And we can go more advanced than this, so we can add more information to each node, and it renders. I know it's a bit weird here, but we'll go more and more advanced, and we'll go quite quickly because I know there's not too much time. For the hierarchy, you can have nested nodes. So this is where we've got A containing two nodes A0 and A1. And you can see on the right, we've got A here, and that contains A0 and A1. And you can connect those to each other. So over here, we've got A1, the inner node connected to B0, which is the inner node of B, and A, the outer node connected to B, the outer node. And you can change this. You can make A connect to the inner node of B as well. So the outer node of something connecting to the inner node of the other. So you update the text, the diagram updates automatically. Quite handy, right? And if we look at styling, so here we've got green A, B, C, D, and if you remember from the previous diagram, there was kind of enough, but then if you wanted to style nodes individually, you can. If you want to style nodes all at the same time, you can as well. I will change the node defaults for the stroke width to be 4. It doesn't work. Let's try that for, there we go. So all of the nodes now have a thicker stroke. So you can have a common set of values which apply to everything. And we can style not just nodes, but edges as well. So if you want to style certain edges as red because an error happened there, that's good. And I mean, you can. Error is not good. If you want to have more advanced styling, you can add CSS animations. Right now, I think the most obvious one is spinning circle. So you can say, I want to make this node have a spinning outline. And if you want to make the spinning outline spin faster, we can change the timing of that. So I change that 0.3 to 0.1 seconds, it spins 3 times faster. If I change that to 1 second, it will spin really, really slowly. And this is a custom animation, so I call it ellipse spin, and the definition is below there. But if we want to have something built in, so Tailwind is the library I'm using. They provide some default animations. So this one's called pulse. You can't really see it on the screen, but the other blue node is pulsing really faintly. So if you want to use the default animations, you can, but generally, I think you probably want to go with a custom animation. Now, we can look at tags. So if I scroll a bit further up, you will see that we've got tags where we define group 1, group 2. Those are these two green things here. I have not defined styling for that. These are all built-in styling. And I've said tag 1 contains nodes A and B. Tag 2 contains nodes B, C, and D. And so if we click on the tags, which is actually quite tricky, there we go. So I click on group 1, and A and B, which are part of tag 1, are highlighted. And if I click on group 2, B, C, and D, which are part of group 2, are highlighted. And we can get more fancy with tags as well. You can style things based on which tag is clicked. So default styling for tags, but custom styling if you want. So over here, if I click on group 1, nodes A0 and B are styled yellow. If I click on group 2, B, C, and D are styled red. So if you want to highlight some part of the diagram, you can. And if you want to say, hey, what's part of both of these groups, then you can click on the other tag, and now it's orange. I put those in, so it doesn't mix the colors automatically. But if you want to create diagrams which are this level of, which hold this kind of information, you can, and you don't have to put it on a whiteboard. It's encoded into the computer. You can come back when you want. If you are working with cloud infrastructure, so this one is the same example as earlier. And let's say you've got lots of cloud infrastructure and someone's trying to figure out which stack creates what, right? So again, with the tags and styling, I click on the global tag. It says, oh, I've created the IAM roles in IAM. And so you know this stack creates those resources. The VPC stack would create the VPC plus maybe a shared subnet for anything that's used across all of the subnets. You can look at the development stage stack. It creates development resources. You click on the prod stage stack. It highlights the prod resources. And that way, if you want to highlight a certain bit of information and you use tags, it's a lot quicker for someone to understand what your infrastructure is like compared to going through, say, CloudFormation templates or Terraform. Like text might be good for a computer to create the infrastructure, but to actually see it and understand what it looks like in the cloud, you want something visual. So if you can go from text to visual and just see the thing, then it's going to help understanding a lot. And if we look at the bigger demo, which is this one, let's say we have a process which we're automating the stack creation of some resource in the cloud. Or it doesn't have to be any cloud resources. Maybe we just have some process which we're automating. We can show step one, we create some things. We spin blue, they're in progress. When that's done, we go to step two, and we notice step one's resources are all green, they're done. We know they're good. Step two, we've got these things happening. So request, return, and process is happening there. And when that's done, we've got our file, we can upload it to S3. And when that's done, over here, we extract the file. I don't know why, but we just have a step there. All right, so if we have this process fully complete, you can see that all of our things have been successfully complete. And if there's any issue with our automated process, we can highlight it red. If we have interactive diagrams which have extra level of detail, you click on the red thing, it shows you, the object was failed to upload. And maybe the extra level of detail is the error of the reason why it failed to upload. Maybe your credentials expired. So that's a lot easier to work with than bazillion logs and Ctrl-F, Command-F, right? So if you can pinpoint the error a lot quicker, then communicate that to the person, and they know where to look. They don't have to find out where to look and then look. And just for fun, I got this done maybe a week ago. So essentially, if you don't recognize what that is, it's a pylon from StarCraft. So I thought it'd be fun if you are creating infrastructure, you've got a warp gate, and then when your server's ready, you've got your server, right? And it's fun. So why not? Cool. So that's what I got for demo. Any questions so far? Oh yes.
Then we also syntax. So in order to do that, we need to learn exactly documentation.
So what you see here is essentially key value pairs. And yes, there is docs. There are docs. At the bottom you will see two links to what styles you can put in, as well as what GraphViz, which is one of the libraries I use, what attributes I support. But some of the other bits, the shape of the input, there is docs, but I think I try to show it by example, so you don't have to read the docs to figure out what to do. Some people just like, oh, I know the shape just by looking at this other shape. That's why I had a lot of different examples, from simple to, well, simple in different areas. So the node hierarchy, the styling, the tagging, all of those have simple and advanced examples. And if you combine those different concepts, you should be able to get something like this.
What's the idea for this sort of to start making a diagram just by writing that there, or actually also having things that convert, say, some Terraform scripts to that then represents it, and then go with that showing a live run of something, say, Terraform setup.
Cool, yeah. So can we show something live based on some existing templates, right? So I will answer this very shortly in the next slides. Yeah, but yes, I created this kind of for that.
Yeah. One more question. Have you looked at other formats like X3D, which is the successor for VRML?
I have not. I've not looked at the predecessor or the successor. Yeah, but I chose a generic format because you can serialize to YAML from any language. But to generate Mermaid.js source code or dot source code in any language, you need to have a library for that, right? And so if you just have a generic map and key value strings, it works, right? So very low entry points. So we want that. Oh yeah.
You chose YAML, not Tomo. Is it because Tomo has some limitations?
I really chose YAML for the referenceable values, but I didn't really think, yeah. And
since this was a whole like static website, does that mean it's possible to download the entire thing and run locally?
yeah, it's good. Yeah, so I know vendor lock-in, and if you don't like the input anymore, you can save the output. And okay.
I guess so. I am assuming that you internally write a YAML which you turn into like graph-based narrative.
Yeah.
So my problem with graph is that I always get stuck on layout. When my stack gets more complex, I just don't like what graphics creates, and then you go into this like weird loop of hey, stack is horizontal and stack is vertically, and then you basically saying, hey, I'll just do it manually on my own or something.
Yeah. So the question is, because I use Graphics internally, the layout's not controlled. So there's a trade-off here, and actually, if I scroll up, there's a second tab called Flex Diagram, where I lay everything out using HTML elements, and I wanted to convert HTML to SVG, but that's experimental. We won't show it today. But in terms of dot laying out stuff, one, I know I hate playing with dot source to get the right layout. So I created that the YAML syntax, which should hide away most of that complexity. I try to magic it up to get something decent, but sometimes my own magic plus dot magic is not good magic. Cool. So because a lot of questions will be answered by the next part, I will jump there right now. So the solution. How does this work? So you don't need to read this. There's two supported usages or two intended supported usages. The first is the manual input. So input by text, and then I generate the diagram, and you can either see it on screen or you can copy it. The second input is as a library. So we want to programmatically input our input, and then we want to generate that diagram and show it. Or right now, I can only programmatically input and then show it in the browser because the generation process uses Graphis dot, and I haven't embedded it into the binary itself. I communicate across the JavaScript. And so it relies on the browser for rendering the diagram part of it. But then it is possible to embed dot into as part of the generation process. I just haven't gotten there yet. May not in this lifetime. I don't know. All right, so with those two supported usages, in terms of processing, I grab the input model and then I convert it to dot source, which we will see by looking at the simple model generated dot. Okay, so okay, you can't read it, but it's essentially I take my text and turn it into dots text, right? So it's a little bit bigger, and the parts that I inject into here are I take your text and then I trap into some structured dot node label, plus I add some classes. So these are Tailwind classes. They do not style the diagram yet. Now, what happens next is we need to convert that dot source into SVG. So I have this example here. This is GraphViz dot one example. They take dots source and they turn it into this. So you can see the similarity in the output already. The layout is about the same. Styling wise, not very appealing, right? So I needed something better for default styles. Now, what happens next is we grab the SVG in the browser and we go, what do? We take away some SVG attributes. So the elements, the SVG elements contain stuff like the text color, the node fill, edge color. Those all override or take precedence over CSS styles. So I take away those attributes and I add one more back to it called tab index. So I add tab index equals 0 to the nodes and the edges, so you can click on them. So if you want to click on the diagram, all of these diagrams are generated using .ix, by the way. I can say, hey, look at that one. Or I can say, what happens next? So we're doing that. So look at that arrow, right? So I wanted to be able to focus on things to highlight that part of the diagram. And also I add, I think that's mostly it. The CSS styles let you do things like, if I hover over this, the color of the node slightly changes. If I click it, it also goes a bit darker. So it might be a bit hard to see on this screen, but you can style them for interaction. And once we have processed our SVG, we need to check it back into the browser page. And then Tailwind, the non-production version, says don't use it. I'm still using it. I'm trying to change that. But it reads the CSS classes and generates the CSS styles on the page somewhere. And so those styles now will be applied to your diagram. And that's how you get the pretty diagram. And there are two variants for output. One is what you see on the page, but the other one for copying is because we generate the CSS styles on the page somewhere else. I do have a placeholder in the SVG such that when you click on the button to copy the SVG, it will go, where's these Tailwind generated styles on the page? It's very ugly to find. You find those and you check them into the SVG and you put that on the user's clipboard. So that's how you get a nice self-contained diagram, fully styled, fully interactive, can paste it somewhere else. And all of the page, well, for all of the slides on this presentation, there's a source link that will link you to the diagram source. And the diagram itself is the saved SVG. Okay, so challenges with this I came across when I was building this is the security constraints. So with SVG, you can have interactivity, but if you want your diagram to render properly in external services, then load inline JavaScript, and it must be self-contained. So don't load the font from a different site. GitHub works on the github.com pages. It doesn't work for the GitHub usercontent.com domain. The content security policy is different across these two domains. I'm sad. Now, the challenge was really adhering to those constraints without subtracting from the appearance, without subtracting from the interactivity of the diagram. And the other constraint, or the other hard thing was, if we want to do some sort of animation, and we look at these three variants, the first one is we have an arrow up, arrow down, green circle. Second, we pulse the green box, green. And then third one, we have a progress bar which goes from left to right. And now the third one is the superior one in terms of conveying a download progress, right? So you can actually see maybe how many %, how far it is. So the challenge with creating good diagrams is actually first think of what you want to show, and can you encode it into the SVG, which dots doesn't let you do. So can you hack your way around that? I hacked my way around it for that, but it's not great. And the other issue here is it works in Firefox. It's a standard animation, but it doesn't work in Chrome or Edge. Yeah, Blink, the engine, doesn't support the standard SVG. I haven't tried Safari. So even if you can think it and you can code it, it doesn't always work. Right, so that's a challenge. Right, so what's next for this project? I need to support images properly. What you saw earlier was a hack where you had to translate images by coordinates. And I want to use unpair, which is a Rust kind of rewrite of Tailwind, or it's compatible with Tailwind, instead of using Tailwind.js, which is not the right way to use it. I use a playground version. And I need to escape values. So if you put angle brackets inside the node information, like the names or the descriptions, it's going to break the dot source. It doesn't work. And the API is not stable. So this is very much an experiment, quite useful experiment. But we're using Leptos 0.6. Leptos has been rewritten in 0.7. So we're also riding on unstable software. So all of those concerns, if you're happy to live on the bleeding edge, then just play with it. And you don't even need to worry about the stability of the library, because .ix, the playground, I try to keep the input format stable, even if the software itself is not stable. So if you generate your diagrams, you save the output, that's always going to work. If you save the input, it might. Cool. And that's all I have. Any questions? All gone. Okay. Cool. I guess all the questions are gone. So thank you for listening, and we'll get ready for the next one.